Okay. Hello, everyone. You're welcome to this program today. I can already see the excitement in the chat section. Thank you all so much for gracing this event today. I am Amarachi Azubike, one of the community managers at She Code Africa. And yeah, I'm excited to have you all here. So I want to know if you're there. Kindly comment with your favorite emoji. I want to know the people who can see me live right now. All right. Okay, so once again, I am very excited to have you join us today. This program, this event is hosted by She Code Africa. And as some of you already know, She Code Africa is a non-profit organization that is focused on celebrating and empowering women in tech across Africa. And over the years, we've been working towards achieving this goal through our various initiatives, our partnership programs, and special events. All right, so last week we made an announcement of our partnership with Demos Cloud Team to train females in cloud engineering over a 3-month bootcamp period. So to kickstart this program, we organized this event with the aim of throwing more light on cloud engineering, what it's all about, and everything you should know about this 3-month bootcamp. And we have speakers from various top organizations right here with us to get you started on that. One thing you have to know is that this event is split into 2 sections, and at the end of each of the sections, we'll be having a Q&A. So what this means is that after section 1, which comprises of 3 speakers, we would have a Q&A in between, and then we proceed to section 2, after which we would have another Q&A. So what this entails is that if you have any question during the course of the event, kindly drop it in the chat section. We would present it to the speakers in that very section to take care of, right? And then one more thing you have to do is to share about this program on your preferred social media handle, tag She Code Africa, tag Demos Cloud, use the hashtags SCAXDemos or SCA Cloud. Once you mention us, we'll promptly share your post across our various channels. All right, so moving forward, I am going to be introducing our first speaker so that we have to keep it running. So our first speaker is right here with us, and he's a cloud engineer at Amazon Web Services, and he is Chidebere Emos. Right? Okay, Chidebere Emos, sorry. And he's going to be taking us through the introduction to cloud engineering and site reliability engineering. Chidebere.
Thank you.
Oh, Chidebube, sorry, I'm mistaking his name. All right. Thank you so much for joining us, Chidebube.
Thank you. Hi, everyone from the team and then the attendees. It's nice to be here. So I'll just quickly share my screen. You would let me know if you can see my screen. Can everyone see my screen? Okay, let me do this. Just a sec. I think I need to just share one more time. Share screen. Okay, cool. Can you all see my screen now? Okay, so I'm supposed. Okay, my name is Chidebube, as she rightly mentioned. I work for Amazon Web Services. I'm a cloud support engineer, and I guess today we are supposed to basically whet your appetite and have you guys grow that interest to join the cloud space, which is a very interesting space, I must say. So let's get started. So before I dive right in, just a bit of history of cloud computing, right? As you see here, I mean, before now, or let's say in the last 10, 15 years, it wasn't a very popular term that you would hear across board. But when the likes of Amazon and Google and Microsoft basically started renting out their computing space, then cloud computing became a buzzword, and then everybody is trying to adopt it. And cloud computing generally is just what you can see around you every day. I mean, most of us on this call today probably have a laptop that have a RAM, that have a CPU, that have a hard disk drive. If you partition your RAM, your hard disk, and then have someone else access your RAM or your hard disk from somewhere else, that's cloud computing. That's basically what the big guys did, and then they are making their money out of it. Before we go deeper into site reliability engineering, there's a need to look at what was available before, what was happening before, and how did we get to SRE or DevOps, as you may see those terms interchangeably. So on the left-hand side of my screen, you see developers writing their code, JavaScript, PHP, Python, whatever it may be. And then on this side, you see operators, the guys who are looking after the servers, who are making sure that there is high reliability, the website is not down, and all of that. And these developers basically write code and then they dump it on these other guys. This dumping can be from, say, they can zip a file and send to them, or they can probably save it in a hard disk drive, or sorry, a floppy disk, and send to them to deploy, whatever it may be. But the developers send their code to the operators, and these operators are guys who, they are not skilled in development. So they don't know how to troubleshoot a JavaScript error or how to troubleshoot a Python error. They don't know how to do their server things, their network issues, fault recovery, and all of that. So you find that the operators will spend a lot of time trying to debug the code these guys threw to them that is not working. Now that means lots of time is spent trying to understand a space that is not really your core area as an operator. And probably after weeks of trying to figure it out, they send it back to these guys, developers, hey guys, your code is not working, please fix your code. So this was what was obtainable before now. And as you know, developers want to build new features, they want to ship code, they want to write it very fast and then meet business needs. But these operators, they want to make sure that their servers are up and running. So if the code was working yesterday, they don't want to hear that, oh, today is no longer working, that kind of thing. So to go deeper into what we're going to see today, I just basically defined some terms here. What is cloud computing? Like if you search on Google, you will find lots of terms or definitions for cloud computing. But I tried to break it down here. I don't want to buy RAM, CPU, hard drive, power supply, or network cables. I also need to run my JavaScript code. From my laptop, I want to run it somewhere else that it can be accessible from the globe. I also need a database to store my users. And then, of course, that is what AWS or Google Cloud and all of those guys looked at and said, okay, hey, we can give you RAM, we can give you CPU, we can give you hard disks, we can give you power supply, we can give you networking. Just pay us some money, and then we give you all of that at the click of a button. That's basically what cloud computing is, allowing users, developers, operators to be able to create servers in the cloud just by clicking a button. Then, I mean, before you talk about SRE, you must talk about DevOps, because you see those terms used interchangeably. So what is DevOps? As we mentioned earlier, developers want to push features faster, right? Operators don't want new changes to break production. This creates conflicting interests. So I want to push a code faster as a developer. Meanwhile, the other guy doesn't want me to push code because his stuff is stable. My site is stable. Don't come and break anything. So it means these two guys are trying to balance out on their own side. Now that is where DevOps now comes in to break that silo, as you saw here, as you see here, to break this silo so that the operators and developers, they can work together because they all have a common goal to serve the customers. So that is where you now have things like the agile methods, implementing gradual changes, automating everything you can, and then you measure everything. So those are basically the DevOps principles, right? And then what is SRE, as you may ask? If you do some research, SRE as a term basically started from Google, right? And some dev advocates at Google says that SRE or class SRE implements DevOps, which basically means that SRE is a way to implement or practically implement your DevOps principles. So how do you automate everything, for instance? How do you measure everything? How do you implement gradual changes? How do you ensure that the developers and the operators are working hand in hand and there's no blame game? Everybody is basically responsible for everything on production. So with DevOps, as I said earlier, that particular silo was broken, and then developers and operators can now work better. So that's where the name came from, DevOps, basically. So things like having daily stand-ups now originated, getting everybody involved from the very onset, not at a later stage, more visibility, and then also having the teams work in the same office also helped with the DevOps concepts. Okay, as you start your journey in the cloud computing space or cloud engineering or SRE, as the case may be, there are lots of buzzwords you would hear. It's so much that if you focus on those buzzwords, you might end up missing out of what you should learn or what you should know. And what are these buzzwords? You will hear things like infrastructure as a service, PaaS, IAC, domain name service, SAS, auto-scaling, load balancing, private cloud, public cloud, CI/CD. All of these words are things you would keep hearing every day in your journey. Even subsequently, for those of you who would end up interning with the sponsor for the program, Demos Cloud, you would see that the team would keep using these words interchangeably or every time. So what I would say is that at your spare time, do your research and find out what do these words mean and how do they tie into the work I'll be doing for my team or whatever I'm learning. Okay, why is cloud important or cloud computing? I don't know, most of you who are following what is happening in the US recently, you would see that Twitter as a platform is banning certain users on their platform. And that has made people to leave the platform to other platforms. And one of those platforms is called Parler and Gab.com, right? This is what the CEO of Gab.com mentioned earlier. He's like, the traffic just keeps growing, hanging tight. Even more servers are on the way. And it's like, we have 10 new servers arriving today and more in the mail coming over the next week. Remember, we own our own bare metal. It's not clicking a button. It takes some time to get things going. So this is the CEO of a company saying that they are going to configure their own servers all by themselves. Now, this shows you where we are coming from in the DevOps space, in the cloud space, and where we are at today. Because today, you need to log into, say, Google Cloud or Azure or Microsoft, or Amazon Web Services. And by clicking a button, you can have your servers all set up. Because cloud exists does not eliminate the need for having bare metal machines. Because as you would see in your career, you would see that lots of companies still want to have the bare metal machines within their organization so that they can probably ensure more security, or have everything in-house, as the case may be. If I go back a bit to the buzzwords, I mentioned hybrid cloud here. So hybrid cloud is a state where you would see that companies want to run their applications in the cloud or across multiple cloud providers, and also have some applications run in-house in their own data centers. So let's go back here. So gap.com basically runs on their own servers. It means that they need to pay for racks, they need to pay for electricity, they need to pay for a server room and all of that. In the cloud, all you need is basically to click a button and everything is up for you. As you start your journey today, or your SRE journey, one thing you must bear in mind is that you need to accept failure as a norm. And because things would always fail, even when it looks so clear that it should work, if you prepare for failure, then you'll be able to avoid it when it happens, or you'll be able to bounce back quickly when it happens. And then some other thing that is very, very important in the cloud engineering space or SRE space is being able to troubleshoot, being able to dive deep, being able to replicate certain issues. Because there are times when nothing is clear, website is down, you are being paged midnight, you're being called upon. And the funny part is that when things go south, you are being held as an SRE, and developers are not exactly held responsible. So you need to ensure that you're able to replicate, you're able to dive deep, you're able to set up processes, as I mentioned earlier, as part of DevOps, that ensures that whatever code developers are going to share with you are not broken code. They are code that have passed various tests. So here are some useful resources that you can look at. I guess I'll share the slides with the organizers after the event. And you can have a look at a couple of resources here. One good one is the SRE book by Google. Very good one to read about. And then this curated resources for SRE engineers. Yeah, that's it from me. So yeah, thank you very much. I think you're mute, Amara.
This keeps happening. Thank you so much, David, for that session. I greatly enjoyed your talk, and I do hope everyone else here enjoyed that talk too. Some people complained about the clarity of the presentation, that's the slides. So Chidiebube has already emphasized that he's going to be making it available for all the participants. So you don't need to worry about that anymore. Okay, so thank you so much, Chidiebube. I'm really, really glad you're here. All right, so moving on to our next speaker. Let's hear from the CEO of Demos Cloud, Andrew Mori. He'll be coming up to give us some talk about the sponsorship and partnership with Code Africa. Hello, Andrew.
Hi, Amara. Thank you very much. Thanks for having me. And thanks to Chidi, the previous speaker. I definitely learned a thing or two. And that's not easy for someone like me to say, who has been in software engineering and programming since before the cloud world even existed. So thanks for that talk. And I definitely learned something there. So good afternoon. What a pleasure to be here and to be able to speak to all of you today. So thank you very much to Ada and to Code Africa as an organization, and to everyone involved for giving me the opportunity to speak to all of you. My name is Andrew, and I'm the CEO of Demos, a leader in cloud engineering professional services and software across Africa. We are the largest Google Cloud partner, and I can talk about the partnership model anytime. So we're the largest Google Cloud partner on the continent, and as you can see, we are growing and looking for talent to join our ranks. We currently employ over 70 cloud engineers, which is a funny term. As Chidi mentioned, we all abide by DevOps practices and we implement them as site reliability engineers. So thank you for having me. I decided to not talk much about engineering, which is weird for me because I'm very passionate about software engineers and the cloud at large. And I expect the course materials and the other presenters to do a much better job than what I could do. I just wanted to say a few things in general about this initiative and about cloud engineering. I forgot to mention that even today, over 40 of our staff members are remote engineers sitting in Nigeria. And I see there are other viewers from other continents or other countries in Africa. And I certainly hope to open chapters or companies in other areas in Africa. And I hope to find young, talented people to join our team and our company. So last I checked, in the United States, about 19% of people in technology in the US are women. I believe this to be much worse in emerging markets like ours in Africa. And I'm here to tell you that the future is female. We all have a part to play in changing this, and I'm proud to be able to contribute to an initiative like She Code Africa. The main reason, from my perspective, of course, this is a subjective thing, the main reason for me, for why we need more women in tech, is because it will ultimately improve technology the world over. Underrepresentation means that entire groups of people and their intellectual capability and capacity is being overlooked. There is a huge opportunity here for businesses, for people, for industries at large. Another reason is that diversity brings strength. Having different experiences, different backgrounds, and different ways of thinking can ultimately improve and produce comprehensive and complete software. Can you imagine artificial intelligence built by men for women? Let's change that because it sounds like a nightmare. So women are arguably, and generally speaking, better at teamwork than men are. And as you know, it's strong teams that perform best, not brilliant individuals on their own. And if you don't believe me, you are welcome to go and have a look at NASA's latest studies on astronaut teams and its preparation for its next space missions. And you'll find lots of information there about teams. So me personally, I've managed teams for over 15 years professionally. These were largely male-dominated teams. During this time, I've had the absolute pleasure of working with really strong female engineers and engineering managers. These examples are Adebola Aduntan, an incredibly strong self-taught software engineer, far outshining her male counterparts in technical prowess, as well as the ability to subtly and effectively manage other engineers. I also managed to work with individual contributors. These are, you can think about individual engineers. Not every engineer needs to be a manager. If you like working with code and you don't enjoy working so much with people, you could follow the individual contributor route. So examples of that are Sinead Dreyer, Somtochi Onyekwere, and Praise Adanlawo, who are widely known within our teams as engineers who write code once that passes code review and goes into testing with little to no failure, which is no small feat. And they do this better than their male counterparts on average. I've also worked with Zainab Ayaliso and Jana Skuman, who continue to inspire me through constantly and consistently being able to think several layers deeper than most, including myself. I'm quite intuitive, and these ladies generally think they think deeper levels, and that I find is very useful, and it inspires me to think more about problems before diving into the code. And this is very close to my heart. I truly believe Africa's largest asset is not its oil or its natural resources, but rather its youth and its intellectual capacity and capability. You are all the future of this continent. Africa's largest export will soon become its intellectual capacity. just like Eastern Europe did, just like South America is doing right now, just like India has done, except I believe we can do it better. Cloud engineering is a wonderful field. Sorry about my dog. Cloud engineering is a wonderful field to get into. It's perfectly aligned with today's world of remote working. It's sitting at the forefront of cutting-edge technology evolution and progression. All the best companies are pouring energy into these spaces. Its very nature exposes you to so much more than simply writing lines of code. It teaches you about automation, about security, observability, things that will give you an edge over standard software development. Finally, once exposed and empowered to what cloud engineering is and can do, it will enable the next generation of builders to build more, to go further, and really put Africa on the map as a place full of world-class engineers. It's already started, and I can tell you clearly that this is only the beginning. I'm very excited to see what comes out of all of these initiatives. I want to encourage you to all take this opportunity and to maximize it. It will not only give you exposure to cloud engineering, software in general, it will also open up the world to you to be able to travel more and take on new opportunities and to become more independent. So, good luck with the program. You are in the best possible hands. And my final words are that, like most things in life, it's really about what you make of it. While people are here to give you a start, to aid you on your journey, the real effort will genuinely sit with you. Don't hold back and wait for someone to do it for you. Take it on yourself to build the future that you want. The future is bright, and yes, it is more female than ever before. So thank you very much. I'm assuming there are probably going to be some technical questions which I'd love to answer. So thank you for having me, and I wish the team the best with this initiative. Thanks, Samara.
Thank you so much, Andrew. This talk definitely deserves a standing ovation, and it's so unfortunate that we are not in a physical space, but then thank you so much. It was such an insightful talk with so many punchlines. Like, if you didn't get punchlines to tweet or share with your friends or even save in your quote box, I mean, where else do you get it? Thank you so much, Andrew.
Thank you very much.
Was really, really awesome. There, this quote you just said something around, can you imagine AI for women built by men? That would be a total nightmare. That really got me cracked up. Thank you once more. Please appreciate Andrew for partnering with us for this initiative. Use the comments he's going to be reading through. He would see all of them. So thank you once again, Andrew. I greatly appreciate your presence here today. So moving on, we are going to be having our next speaker, by name Adora Wodo. I was about calling her Adora Hack because that's what she popularly goes by. She's a software engineer at Microsoft, and she's going to be talking on the topic skills for excelling in site reliability engineering and cloud engineering. That's a long one there. And before she comes up, please know that this is the last speaker for this section, and after her talk we are going to be having our Q&A before we proceed to section 2. So if you have any questions for her or our two previous speakers, use the comment section. Remember, I'll be presenting it to them immediately Adora leaves the stage. Welcome to the stage, Adora.
Thank you so much, Amara. Good day, everybody. I'm so honored to be here today. I'm just going to jump right into this now and share my screen. I don't know if my screen is visible. Please let me know. Okay, cool. It is now. Okay, so today I am going to be talking about skills to excel in SRE and cloud engineering. From now, like from this point forward, I'm just going to be talking about cloud engineering alone, and in a few slides I will tell you why. But before I jump into like anything properly, I would quickly want to introduce myself. Amara kind of did a good job at doing that already, but there are some other things I'd like to mention about myself. My name is Adora, and I am a software engineer at Microsoft Mixed Reality. So I spend my time building cloud services that allow other developers all around the world to build amazing mixed reality experiences. So I am in that, cloud service engineering space, essentially. I'm a tech content creator at Adora Hack, like she mentioned. So that's my blog and my YouTube channel. I am on the advisory board for VRAR Nigeria as well, which is a community for mixed reality enthusiasts, and we're trying to grow that space in this region. And I'm also a DJ on Instagram Live and on some weekends. So now getting into the main gist of the day, I'm going to give like a quick, cloud engineering overview before I go deeply into it. But I wouldn't talk as much as I planned to initially because the first speaker, already talked about cloud computing, which is the basis for all of this, to begin with. Cloud computing is basically, doing your computing over the internet, and it gives you the flexibility to not worry about so many things. Like, you pay for the resources that you need to pay for. You focus on what's important so you can be more innovative and you can be more productive. You don't waste resources on things that you don't need to waste resources on because you are using a public cloud or some kind of hybrid cloud. You're paying somebody else essentially to use their cloud, and you only pay for what you use. So that gives you, like, the whole economies of scale as well. And because cloud computing exists, because a bunch of companies, a bunch of people, different people are moving their computing to the cloud today, we have this term, which is cloud engineering. And it's like a field of engineering that focuses on cloud services in general. So I see cloud engineering as, an umbrella term for doing engineering in the cloud. So you would be doing some kind of software architecture regardless, because you would have to, design what your cloud applications would look like. You're going to be doing software engineering still because you're going to be writing code. There's DevOps, there's the networking bits, there's the infrastructure engineering, and there's like so much more. Like, it's a lot. And site reliability engineers are engineers that like help teams find a balance between like releasing new features and making sure that they are reliable for users. These teams use software as a tool to manage systems, to solve problems, and to automate their different tasks. And being someone in the infrastructure engineering space, SRE space, DevOps space, you'll be doing a lot more of these things. But cloud engineering is more like the umbrella term. It's like any field of engineering that you are in, so far as what you are working on focuses on cloud services, essentially you are doing stuff in the cloud. And then there's this diagram that kind of buttresses my point, kind of says that cloud computing is the entire thing, and then you have like, cloud engineering, you have SREs, you have all these other things inside. Because the truth is, if the cloud did not exist, if these companies did not, start thinking in this direction, or even if it wasn't them, but if nobody started thinking in this direction and cloud computing wasn't a thing, we would not have cloud engineers, we will not have SREs, we will not have DevOps, and maybe we would in a different way, but the way we know it right now wouldn't have, been possible. And like I mentioned already, when you're doing things on the cloud, the three main things I want to touch on are software architecture, which is, you're going to think about the application that you are building. You're going to, design, you're going to think about the architecture, you're going to design that cloud application, and there are going to be like so many things you think about. You're going to be thinking about, how you want to handle like load. If you have like multiple users, you're going to be thinking about scaling, you're going to be thinking about a lot of things, and you're going to design your application with those things in mind. You're going to be writing code regardless of whatever it is that you're doing, right? You're going to be writing code. So software engineering is still something that is valuable in this regard, and something that is also very important. I don't want to say is the most important, because they all like work together and go in hand, but DevOps is something that is also very important. And in DevOps, I'm going to be like, I kind of broke it down into these two things, being like SREs and infrastructure engineering. DevOps is a whole lot. I don't think I can use the 20 minutes I have to talk about DevOps. It is not going to be enough. But if you have any other questions, I am ready and available to answer all the questions that you have. And I already defined SREs, and then I'm going to talk about infrastructure engineers, which are people that focus on, creating and provisioning the infrastructure for your cloud application. And that's why I sort of grouped it on that, that DevOps region as well. Before I go into the skills that are important, right, I want to tell you why it is even important to be, to look into cloud computing or cloud engineering or this field in the first place. And that's because right now there's a high demand for it. Initially, when I was defining, cloud computing, I talked about economies of scale. I talked about flexible resources. I talked about it's like making people more productive. And in that regard, a lot of companies, a lot of people are moving in that direction of doing everything in the cloud. And this means that they're looking for cloud engineers. They're looking for people like you that they can hire. I found this, I did a random Google search, and then for like cloud engineer job, I really don't remember the name of this website right now. And it was about 182,912 jobs that I found that different companies globally are hiring for. And there's a high demand, and there's also the potential of earning more, because I'm not really great with economics, so I'm not even going to try and drop that supply and demand line. But like there's a high demand for roles. People are willing to pay good money to get great talent to fill those roles, essentially. And also there's also the probability to have like job prospects in multiple industries that use technology, or multiple industries that are technology enabled. So it doesn't have to be, a tech company. Like it doesn't have to be like, you working in AWS, or you working on the Azure team in Microsoft, or working in DigitalOcean, or working on with the group of people that own GCP at Google. You can be working in a different company, and because everyone is moving their everyone is moving their computing, to the cloud. Everybody is moving their business, to the cloud. Essentially, you would have a place in that company, regardless of whatever their main industry is, so far as they are tech enabled. So I want to talk about now the skills that I believe that you need to excel in cloud engineering. The first one, which is a no-brainer in my opinion, would be cloud service providers, understanding how to navigate your way through these popular platforms: Azure, GCP, AWS, DigitalOcean, and so many more. Understanding these platforms, knowing why they are important, being able to navigate your way around them, understanding the resources that can be provisioned in these platforms, and like why these resources are important. Something that I think is really useful is programming knowledge. Regardless, I don't think that ever goes to waste. I put query languages here because if you are a DevOps person and something goes wrong, if you're a DevOps person or a site or an SRE, for example, and if something goes wrong on the application that you're supposed to be managing, right? Or that on the application that your team is supposed to be managing. More often than not, you would have like to go check logs, figure out what happened where, and sometimes you'd have to query those logs to give you insight on the issue that was caused and what caused that problem, and then you can think about how you want to go ahead and fix that. So there are multiple query languages. The common ones that I would say that I have used in the past and I currently use today are SQL and KQL. KQL stands for Coastal Query Language, in case anyone was confused. Version control is important as a programmer. You're going to be writing code, you're going to be checking that code into source control. You're not going to be sending random zip files to random people. You're not going to be writing the code for yourself by yourself and have it on your box, because they're not going to ship your box to production, right? So version control is something that is also really important. Programming languages as well, JavaScript, C#, Golang, TypeScript, and any other language that you can use in the cloud. It's also important to understand, APIs and web services. Also, because there's like the benefits of cloud computing is that everything is now on the cloud. You have on-demand self-service. You can be more productive. There's economies of scale, so you don't need to pay for something until like you actually need it. These benefits sort of come with more responsibilities as well when you think about security, because now it's like your application is in a public place, and if it falls into the wrong hands, you're doomed, essentially. So you need to also understand that security is important and learn about different ways to enforce security, different things to do when writing code, when provisioning infrastructure, when being an architect, a software architect, different things that you need to know to help you properly enforce security in your application. Also, disaster recovery. If anything happens to the application that you are building or that your team is managing, you need to be able to recover quickly from that. Threat modeling, I would also put under security as well. And threat modeling is a way that you can like design when designing your system, you think about, okay, so these are the possible threats that can happen in my system, and this is a way I plan to mitigate each particular threat. Like if authentication is like a very possible threat, now you might be thinking about, okay, or if identity is a possible threat, you might be thinking about, being able to enforce authentication in a way that is very hard for attackers to breach and different other things. But this also falls under security. Operating system, something that's very important as well, depending on what platforms or what operating systems your team will be using more often than not. You would need to understand that it's important to know about like Linux and Windows beyond the surface of just being able to push a button and launch an app and navigate and use it. Like you need to know a bit more than you currently do. Infrastructure engineering, you need as someone in that DevOps space in the cloud engineering umbrella, containerization is something that a lot of people are beginning to look at nowadays. Like we're having Docker, we're having Kubernetes, we're having all these really amazing things. Virtualization as well. Infrastructure as code is something that in recent times has gotten popular and is still getting popular, to be honest. And there are various amazing tools that you can use to do infrastructure as code. And if you're wondering what infrastructure as code is, as a DevOps person, it is being able to write code for provisioning your infrastructure. So as opposed to opening GCP or AWS or Azure to create a serverless app, to create a database, and having to write those configurations somewhere manually and always go back to it when it is time for you to revise what you've done, because you need to update it or you need to stand up like an entirely new setup that is supposed to mirror maybe the old setup that you've done. If you have like infrastructure as code, it's going to be very easy because now it's like you're writing code in different ways. Different platforms use different things. Like Terraform has its own thing called HCL, which is like the language that Terraform uses for its IAC. Pulumi gives you the ability to, do your IAC stuff, like write code in normal programming languages, and you can use that to define your application's infrastructure. You need to have the same way you need to really understand operating systems and have your way around like different terminals. And have your way around different operating systems, it's also important to be able to navigate different terminals and write these bash scripts where necessary and everything. This is a shameless plug again because I'm a Pulumi fan girl. Pulumi has saved my life a million times, because if I had to maybe do infrastructure as code and I had to learn like a totally new thing, it would have just annoyed me because I'm a very lazy person. But being able to create infrastructure for my multiple cloud applications using a programming language that I already know is a gift. And that's why I had to just plug this in, something that I would suggest anybody can check out if they have the capacity to. So something else I want to say, how do you get started with cloud engineering? The first and the most important thing, as we are all here today, is that you should please take this initiative very seriously. I really appreciate everyone on the whole like She Code Africa team with the amount of work that they put in to make this a success, and the other initiatives that they do, to be honest. So please, just so that their work doesn't go to waste, and also for your own good, take this initiative seriously. These are links as well that you can check out that can help you in your, cloud computing, cloud engineering journey as well. I would have these slides up and I would share a link on Twitter so you can check it out. So you don't really need to take any screenshots if you don't have it today. The last bullet points for me is the internet, because I cannot list every single resource on the internet. If you have internet access, you are blessed. So I would suggest that you just go out there and use what you have essentially to be the best cloud engineer that you can be. Thank you very much for coming to this talk, and I will be checking if there are any questions that might need my attention as well.
All right. Thank you so much, Adora, for that spectacular session. Thank you so much. This is actually time for Q&A. So all the speakers in the first session will be called up, and I've collated the questions for you. But before we go into the Q&A session, I'd love to know how many people here that has been tweeting or sharing about this program on their social media pages. If you've not done that, this is also the time for that. So as we are having our Q&A, feel free to tweet about the program. Use the hashtags SCAXDemos and SCA Cloud. Also tag She Code Africa, tag Demos Cloud, and we would share promptly. All right, so it's time for Q&A. Let's have our speakers on stage. All right. Welcome. Please don't forget to tweet about this program. I'm checking. So, all right. So the first question we have here is by Stacy Honora, and she directed this question to you, Andrew. She's asking how you keep up with evolving technologies, even becoming one of the key players in technology. Is there any tip for that?
It's a great question, and a loaded question too, because it's not easy doing that. But I think it's probably more important to focus on the fundamentals than jumping onto hype. And the reason for that is because there are fundamentals that will stay regardless of what new technology comes out. So crazy things like the ability to troubleshoot, in my opinion, is a fundamental that will do you well, doesn't matter what language or what cloud platform you use. So it's not that I'm not trying to answer your question. I just think that there's more value in focusing on fundamentals before trying to adopt the latest technologies. It depends where you are in your career. So I would say if you are starting out, forget some of the noise. Focus on the basics and focus on the fundamentals. There'll be plenty time to try out new wonderful tools like Adora suggested. For example, we use Pelumi a lot, and it definitely helps us as well, because bare bones infrastructure as code can be a lot of YAML and difficult to maintain. So I think once the fundamentals are in place, it opens you up to try new things. And perhaps that's the answer to your question, is to remain curious and be unafraid to try new things, because there is value in this technological progression and evolution. So sorry for the roundabout answer.
It's okay. Thank you very much. I hope that answers your question. All right, so we have a couple of questions which I have summed up. So this question is by Elizabeth, Matilda, Chinonye. A lot of people ask the same question, and they want to know what steps a complete novice in cloud engineering should take. So Adora, do you mind answering that?
I don't mind. The steps a complete novice should take: join the bootcamp, in my opinion. Steps to take, I would suggest, do that, or maybe take I believe that for you to be here, right, there's a chance that you wanted to join this in the first place. So go ahead and join it and let that be, where you start from. Or you can take, different courses online. You could take, I know that all these different platforms, Udemy, Udacity, probably educative as well. They have, different DevOps or, software engineering, cloud engineering tracks that you can take to help you out. Just decide. I mean, I mentioned 3 things. If you want to be the architecture person, that design person, if you want to be the engineer, still writing code, but now you're writing code in the context of, like, I'm building a cloud application. I mean, this is how I should be writing the code. Or you want to be in that DevOps place, like you want to be the one taking all the hits, essentially, because they are the ones that really suffer, right? You can decide to make that decision and then find a resource that will help you learn. Yeah. So I'm done answering the question. If there's another question.
All right, thank you so much, Adora. So we have another question by Temitayo. She wants to know what opportunities exist for beginners and intermediates. I believe in cloud engineering specify, but then that's what we are talking about.
Is that my...
Chidiebube, do you mind?
Okay, it's fine. She's asking opportunities for beginners and intermediate people, right? Did I get the question correctly?
Are we still here?
Can you guys hear me?
Can you hear me?
Okay, yeah, cool. Yeah, so for that,
intermediates, yes.
Intermediate, yeah. So just like Adora mentioned, if I think back on what she mentioned earlier, the fact that even as an SRE or DevOps engineer,
yes, I can. Clear.
You having a programming background or that knowledge kind of like helps you out. So yes, there are opportunities for intermediate developers. If you, let's say you're in a team, for instance, and then, but you are writing code for them as an intern or a junior developer, but you see some guys who are the ones in charge of deployments and pushing code to the server, you can express your interest to join that team because you want to be a part of the SRE or DevOps team. So in that line, there are opportunities. Now, what if you want to apply directly without being in a company? Let's say you already have programming background and want to apply. Then also goes back to what was mentioned earlier. Learn some skills, look at job postings, and then try to work back on them. They're asking you to learn how to do Python scripting, how to do Bash scripting, how to understand networks. Look at those job postings, piggyback on them, and then learn those skills and apply for those jobs. If you show that you have programming background and have learned those skills with some certifications, then you'll get a job. I don't know if that answers the question correctly, or someone else have anything to add.
Yeah, I believe it does. I believe it does. Thank you so much. All right, so we have a couple of questions remaining here, but before we continue with those, I do hope you are sharing about this program on your social media handles, Facebook, Twitter, Instagram. Share about this program, share about the events. Don't forget to use the hashtags to share about the events, and tag She Code Africa and Demos Cloud, so we would share your post as well. So we have another question here by Chidiebube. Okay, the person is addressing the question to Chidiebube, and she wants to know the difference between SRE and DevOps. Is there any difference between these two?
Okay, in my opinion, because if you go to the internet, you would see lots of opinions out there. But as you study, you get to form your own opinion. If you do some reading, DevOps is more of principles, philosophies, ideas, concepts, agile methods, small increments of changes, all of those things. Now, SRE as a term basically implements those DevOps principles. SRE is now the action, the specific actions you take to implement DevOps principles. So that's the difference that you would see. Also on the internet, you see that most job postings kind of use both words interchangeably, or both terms interchangeably. So they want to hire for DevOps engineers or SRE. So yeah, so DevOps is philosophy, SRE is implementing those philosophies. Yeah.
Okay. Thank you very much. Okay, we still have time for just a few more questions before we get into section 2 of this event. So Rhoda is asking if one must be a programmer to be a cloud engineer. Anybody can take the question. It's not directed at anyone.
Okay, sure. I would say that going back to what Andrew talked about just knowing things fundamentally, I would say that knowing, like, being a good software engineer, being a programmer would pay you in the long run, essentially, because there are some things that you understand and it will help you basically do things faster and make some more decisions. However, if you are going into cloud engineering and you're thinking about being an SRE or being a DevOps person, if you don't work in a company that maybe uses Pulumi, like I talked about, for example, where you have to like actually write code to create your infra. If you're going to be writing a lot of YAML and JSON, then I wouldn't necessarily call that programming. So just do that, But I would say that if you have a programming background, it will help a lot. But I don't think it's something that is a blocker. Like if you don't have it, then you can.
Yeah. Let me just add to what
Right.
Adora mentioned. Yeah.
Okay.
So yeah, like practically, for instance, if you if you know how JavaScript works as an SRE, can you guys hear me? If you know how JavaScript works as an SRE, the fundamentals, as Andrew mentioned, when you deploy JavaScript code to the cloud and it's broken, you can sort of interpret what issues is going on, then even relate that to the developers. But if you don't understand those fundamentals, then you may struggle. Secondly, as an SRE person, you need to know how to be able to write bash scripts. So bash is a programming language. It's a programming language like every other programming languages. You do if-else statements. You do for loops in bash. So you need to know that, be able to automate a lot of things. So I would say fundamentally, you need to be able to write at least bash, at the very least, bash programming. Yeah. And then, of course, if you want to go deeper, Python and then Golang to build certain tools. Amara, you're mute, Amara.
So, oh my. All right, that must have been the host. Okay, let me get the question. We have a very interesting question. I'm trying to get that. I hope it hasn't cleared out. Okay, Amarachi is asking, since DevOps engineers use tools to automate network operations, what exactly happens to the role of network operators, or do they become DevOps engineers?
I
hope you got the question.
That. I have got the question. I also saw it in the very interesting question. I would have never thought to ask such a question. I think the reality is the role of a network engineer in the cloud for most cases will reduce, because that's half the point of the cloud, is that we rely on Google for its own proficiency within its network. We rely on Amazon for its own network. And all of that network-related stuff, not all of it, but a large portion of it, is abstracted away. That wonderful example that Chidibube used with, I think it was the Gab, with buying new servers, they would need network engineers to set up those networks. Where in the cloud, if you're using containers in an orchestration layer or even load-balanced auto-scaling virtual machines, you don't have to do that. You don't need to understand and control the network to the level that you would need to do for your on-premise or your own hosted servers. So I think the answer is almost yes. It depends on the use case, and it depends on what your company or what your project is doing. But essentially, large portions of network operations are abstracted away. That doesn't mean there is no place for network engineers in the cloud. Like I said, it really depends on the use case. And, you know, a seasoned engineer like me knows that if something's broken, it's usually network related. So like DNS or IPs getting lost. So yes and no. It's a really interesting question, and I'm not sure there's a single answer to it.
All right, thanks so much, Andrew. We've come to the end of this Q&A session, so we are going to be getting into section 2 of this event today. Thank you, Adora, Chidiebube, and Andrew, for taking your
Hi everyone. Really sorry for the break in transmission. So just like expected, we can't really trust the internet to prove us really well. So I'm going to be calling on the next speaker. Her name is Bukola Bisuga. Bukola is a software engineer at InterSwitch Groups, and she's going to be speaking on breaking into the field. She's going to be talking about the different fields and the different careers in cloud engineering and how you can get started. And also, if you're trying to switch from a different field into another field, into cloud engineering, she'll be giving the tips as well. So welcome, Bukola. Hi, Bukola.
Hi, good evening. Hi, everyone.
Welcome. So I'll be leaving the stage up to you now.
Okay, thank you very much. Hi, everyone. Really excited to be here. I hope we all enjoyed the program so far. Okay, so I'll just share my screen now. Okay, I hope everyone can see my screen. Can anyone see my screen? Okay. Okay, can everyone see my screen now? Okay, hi everyone. My name is Bukola Bisuga. I'm a software engineer at InterSwitch Nigeria, and I build financial services and applications that run on the cloud at InterSwitch. We have some products like QuickTeller and a few others that you might have heard of. So I'll just get right into it. Today I'll be talking about fields and careers in cloud engineering, getting started or making the big switch. Either ways, it's really pretty much the same journey, the same principles, regardless of whether you're just breaking in as a novice or you already have experience as maybe a software engineer or a developer, whatever the case may be. Okay, so previous speakers have spoken on cloud computing and about the cloud, the global network of servers that's accessible over the internet. So if you've pretty much used Gmail or Dropbox, Google Drive, OneDrive, and the rest, then you've experienced the cloud. So just as previous speakers have said, cloud computing is just the delivery of these computing services over the internet. There are three major cloud computing stacks, and I'll just quickly run through them. So we have the infrastructure as a service, the platform as a service, and the software as a service. So as a cloud engineer, you want to know these basics. These are the basics of cloud computing. They form the foundation. And these are things you want to know, especially if you're just getting started or you're deciding to make the switch into the field. So infrastructure as a service basically just provides the infrastructure, like the name says. So it provides computing infrastructure that is managed over the internet per se. So I believe just like Adama have mentioned before, you have like Sony and a few others that provide this service already, infrastructure, just the infrastructure. The infrastructure is basically where you host, kind of. So you can say, oh, infrastructure is to host. And then the platform as a service provides like a framework that you can use to now build on. So if you're hosting on infrastructure, the platform as a service provides you that platform code to build your services as well. So it provides you options like operating systems and the databases and language execution environments and so on. So software as a service is probably the most popular cloud computing category. And if you use Google Apps or Dropbox, and the likes, then those can be classified as SaaS products. So software as a service is the product itself. So it's the actual product that is consumed by the customer. So infrastructure as the host, the platform as the build, and then the software as a service as product or the as the product. So previously, as compared to the on-premise mode, cloud computing has become like fast rising, and you're probably wondering why all of a sudden. It's because it has much more advantages than the on-premises means of infrastructure. And some of these include the cost savings, security, reliability, scalability, because you have access to an unlimited amount of space, storage, and servers that are just sitting down in the cloud, that you can, tap into, that you can deploy your applications across various virtual machines, and so on and so forth. Also provides a good means for disaster recovery as well. And basically helps you just like focus on building as opposed to having to focus on hosting and all of that. Cloud computing has enabled us to be able to just, I just want to build my product. I just want to focus on my customers and let them do the rest. Some of the cons could be related to limited control. You might not have as much control as you would have if you were using the on-premises means. And also, it relies heavily on internet connectivity, meaning you need access to internet to be able to access most of your stuff that's on the cloud. Another con could be vendor locking. There are so many cloud providers right now. There are a couple of popular ones, and decide you don't want to use this cloud provider, you have to move to another one. That could also be a stressful process. Okay, so moving on. So cloud engineering, simply defined as a systematic approach to cloud computing. It's pretty verbose, and it involves programming, DevOps, networking, security, databases, and all of that. So now you're thinking, okay, why should I become a cloud engineer? Or I'm already a developer, or I'm already this, or I'm thinking of how to break into the tech industry or ecosystem. Well, it is currently ranked as the most requested skill for tech or software development positions, and it has like over 90,000 job listings. Just like one of the previous speakers had mentioned, if you do a Google search right now looking for jobs in cloud engineering, you're going to get hundreds of thousands of job listings, probably over 100,000 right now. And also, if you're very creative and you feel like, okay, you've had some experience, let's say you've had some experience in software development, and you want to explore more options outside of that while still being able to use your software development skills, well, cloud engineering allows for that. That way, you're solving real-world problems, utilizing skills in DevOps, web security, networking, system design, containerization, and the rest. And also, last but not the least, another reason why you would want to become a cloud engineer is because salaries are becoming attractive and more and more attractive as we go on, because there's a huge spike in demand, and really it just really attracts high salaries. So that's also a good reason. You don't need to be shy about that. So your role as a cloud engineer will probably be centered around planning, designing, managing, maintaining, and supporting cloud computing services and softwares that are running on the cloud. So let's move on to careers in cloud engineering. So there are a lot of careers in cloud engineering, but usually they all fall under one or two of these three major fields. So we have the cloud architecture, we have the cloud development, we have cloud support. Cloud architecture basically involves, planning, designing, and generally the word architecting the cloud computing infrastructure of an organization. Cloud development involves the building, deployment, and optimization of cloud-based applications. So usually you find the cloud engineers and the cloud developers in this category. Also, there's a cloud support. Now, these guys are more customer-facing. they're involved with troubleshooting, maintenance, and onboarding for clients' cloud computing solutions. Okay, so going deeper into the cloud architecture, the major role here is the cloud architect. So depending on the organization or the recruiter, you could have different names, cloud solutions architect, and all of that. But generally, the main role here is cloud architect. And what they are mostly responsible for is overseeing large portions of the cloud network. They evaluate cloud performance regularly. They work with the cloud engineers and support teams to develop technical solutions when they're faced with challenges. And they also are responsible for planning and management of all cloud components, including hardware, software, or other applications that are running on the cloud. Okay, so moving on to cloud development. So this is where cloud engineers and cloud developers come in. These are the major roles in here. And you can see from what I have here, they're really synonymous, really. So the title shouldn't really bother you. There could be other roles under this cloud development, especially since as we know that this field is constantly growing and developing. So just focus on the roles and the responsibilities rather than the titles. So the cloud development roles are usually focused on developing cloud architect vision into code. So yes, these are the coders, these are the programmers. So they use their programming skills alongside cloud-specific skills and knowledge to build and deploy applications to the cloud. They also utilize other things, like I mentioned earlier, DevOps, computer networking, app development, system design, and whatnot, to also ensure that they can deploy these applications to the cloud successfully. So cloud support. So yes, these are more customer-facing roles. Some of them include cloud support engineer, the cloud systems engineer, the cloud security engineer. And like I said earlier, they work directly with the cloud clients. They help to maintain individual cloud components for these clients as well. And they're also available to assist clients and also work with the cloud architects and the cloud engineers to resolve customer issues on a larger scale when they arise. So just because your job role doesn't have cloud in it doesn't actually mean you're not working in cloud computing. There are a list of other roles that you find when you're looking for a job in cloud computing or cloud engineering that don't have cloud in them necessarily, but are tightly intertwined with cloud computing. We have like the data engineers, the software engineers, DevOps engineers, software architects, cloud systems administrators, the cloud security engineers. And also, if you're thinking, are there any cloud roles that don't necessarily involve coding? Maybe there are some, like the cloud sales. These are the guys who focus on selling these cloud products to clients as well. So that role is also an option. So I'll advise, if you're really interested in breaking into this field, this industry, cloud engineering, do your research, find out what you're interested in so that you can tailor your learning to suit that path. If you look at the description for most of these roles, they're quite similar. Like I mentioned, they all fall under either the cloud architecture, the cloud development, or the cloud support. Okay, so now we'll talk about getting started. So you could either be wanting to transition into cloud engineering roles, or you don't have any experience in tech at all and you want to get started. Like I said earlier, the paths are really similar. You need to have knowledge on programming and version control. So this is very important. Like previous speakers have mentioned, you're going to be working with terminals, you're going to be writing scripts. So programming is really important if you're going to want to appear, hireable to a lot of recruiters, especially if you're just starting and you're looking to gain a lot of experience. Programming is like the base that you can have to even, be exposed to those kind of opportunities. So once you have programming knowledge, you have knowledge in operating systems and terminals, like Linux as an operating system is one of the most popular ones that is used right now for in a lot of cloud service providers and all of that. Bash is also one of the most popular scripting terminals that we have. Also, you want to learn about databases. You want to know when to use what kind of database, what kind of data storage and not. So you want to focus on learning about all of that, how they apply different kinds, the kind of data they're best suited for, file storage, video storage, imagine products like YouTube that you're constantly streaming videos. You want to know what kind of storage they're using. You want to know how they're able to connect so fast any video you click and stuff like that. So yes, you really need to understand how databases and data storage works if you're going to get a job or get started in cloud engineering. So web services and security is also very important. If you're going to be a cloud engineer or you're aspiring to be a cloud engineer, you need to focus on APIs, authentication, security, and all of that. So that's also another very, very important part of becoming a cloud engineer on your cloud engineering journey. Another very important one is virtualization and containerization. Some of us might have heard of Docker and Kubernetes and virtual machines, and really running on the cloud. If you're building and you're trying to scale your application, you're going to be dealing with a lot of virtual machines. So you need to understand the theory behind how virtual machines are created. Even though, on the cloud, you just click your button or type a script and everything works, but still having that foundational knowledge will help you, because that way, it doesn't matter the tool that you're using for this. You already have the background knowledge, and it's really going to, you're going to stand out from other people once you have your foundational knowledge instead of just focusing strictly on tools. Another great thing that you need to learn on your journey is software lifecycle and development operations, DevOps. You need to understand the entire lifecycle of software development applications. You need to understand from the coding, from the system design, architecture, to coding, deployment, pipelines, taking them to the cloud, and so on and so forth. So having a good understanding of this will really help you know where you fit in. And if you're even applying to an organization, you best know what suits them, or if you know what they're using, you can bring up suggestions and stuff like that. You have to stay curious. You have to learn. You might not be able to do everything, but it's good to have that foundational idea of how everything works. So another very important thing is gaining hands-on experience. It might be tough. You're a beginner. You don't have so much experience. You're not really coding, or you haven't really been coding for a while, and you're trying to break in fast. Well, the fastest ways is through hands-on experience, and you can get this through open source projects. There are a lot of open source projects on GitHub. Just a Google search. The internet is your friend. Just do a Google search. You find a lot of open source projects that you can learn from, not only learn from, contribute to, and start building your skills and experience from there. Also, there are a lot of remote internships that offer you the experience and the opportunity to apply your skills and also learn. So I'll suggest searching and looking out for such opportunities. Even in Nigeria here, it doesn't always have to be remote. There are a lot of companies who are now recently breaking into cloud in Nigeria. So it's easy for you to, understand, shoot your shot in code and find a space, find a spot for yourself and learn, because experience really is the best teacher most times. So troubleshooting and problem solving is like a general skill everyone must have, regardless, cloud engineer, beginner, software developer trying to transition. It's really important for you to understand problem solving, to be curious, to know how to troubleshoot, to know how to find solutions to problems. And last but not the least is getting certified. Last but not the least is getting certified. So there are a lot of certifications out there. Microsoft Azure certifications, Google Cloud Platform certifications, AWS certifications that will help you. Now, these certifications are tailored to prove that you actually have experience, both theory and practical experience, so that when you're job hunting or trying to get hired, your employer or the recruiter knows that, okay, you have experience being certified by this or that cloud service provider. So yes, there are three major popular cloud services: Amazon's AWS, Microsoft's Azure, and Google's Google Cloud Platform. Now, there are a couple of others, DigitalOcean and a few others, but if you're looking to get a job, it's best to focus on what is in right now, because there will be a lot of opportunities out there, but if you don't meet certain requirements or you don't have certain knowledge of the tools that they use, it might be difficult. So you don't have to be an expert per se yet, but having an idea or an understanding of how these popular cloud services are run is very, very important. That way you're able to apply it to solving real life solutions. You know what the company does, you know what cloud service they're using. You can kind of put things together and understand how the flow works generally. That way you're more hireable. Okay, so there are some helpful links that I've attached at the end of my slides, and there are free courses. There's a free course on Udacity that does a proper introduction to cloud computing, like from zero. So if you're a total beginner, it's fine. There are a lot of free resources out there. Pluralsight is also really great. They have learning paths for cloud computing and cloud engineering that you can follow. And also, Google Cloud Platform, Microsoft Azure, and AWS have free trainings on their sites that you can use to learn more about their platforms and practice hands-on and really get that experience. So it'll be really good for you to sign up for this and begin your learning right away. There are also jobs and internships scattered everywhere all over the internet. LinkedIn is my favorite to go. LinkedIn jobs, lots of internships, local and remote. I've also attached some other links as well that I think you might be able to find remote internships and jobs that are great for beginners and intermediate as well. So yeah, sign up on the SheCode Africa Slack channel and join the DevOps channel. Yeah, we have a lot of people learning, beginners, intermediate. We have experience and experts, people who are there to answer your questions. So please sign up, join, and introduce yourself. We're here. We're glad to have you join us. Another great community to join will be the Digital Ocean community as well for your DevOps learning or your cloud engineering learning. Thank you.
Thank you. Yeah, thank you so much, Bukola. That was very well broken down, and I do hope everyone watching really learns a lot from that session.
Thank you.
Thank you very much once again, and I apologize for the slide. All right, so thank you very much, Bukola. If you're just joining the program, this is the second section of this event, after which we would have a Q&A. So I'm currently taking your questions. So if you have any questions for any of the speakers, drop them in the chat. At the end of these sections, they would come up and answer all your questions. Feel free to share about the program on your preferred social media channel using the hashtags SCAXDemosCloud and SCA Cloud. Okay, tag SheCode Africa, tag Demos Cloud, so we can share your posts. All right, coming right up is our next speaker, Uche Nebedum, a software engineer at Optical Inc. He is going to be talking to you about what a typical day in the life of a cloud engineer looks like. Uche Nebedum, I hope you're here with me.
Hi everyone, my name is Uchenna Nebedu, and It's nice to be here. I am a senior software as a service engineer with Optiva. I will share my screen with you quickly. Okay. Can everyone see my screen now? I should guess so. Okay, yeah, so we're going to be talking about a day in the life of a cloud engineer going forward. So we're going to do this. I'm going to introduce a couple of concepts that are related to cloud engineering. We'll talk about 3 specific roles, which is a cloud solutions architect, cloud operations engineer, and a DevOps/SRE engineer. These are roles I have worked in the past, but I will be using 3 aliases to take you through this role. And then technologies, I will mention a couple, and then we can move to the Q&A and everything. So my colleagues and everybody that has talked talked about cloud computing and mostly everything around that. So one thing I would like to mention is that so for the actual cloud, we don't have just the public cloud. There is the private cloud, which is when people buy their own infrastructure, virtualize it, and run their own workloads there. So it is also an aspect of cloud that is still very much in play, which is it's also necessary. So there are two specific people that make use of the cloud when we talk about cloud. So there's the cloud providers and there's the cloud consumers. So on the cloud provider side, we have technology providers that provide the technology that is actually the cloud. So in this, we have AWS, Google, and Microsoft. And then we have consulting providers that their job is basically to help people utilize the cloud or provide professional services. Like someone wants to move to the cloud, they need to deploy an application to the cloud. These are the people that would help you do that if you don't want to do it yourself. And then on the cloud consumers, we have end users, which is like you and me. I can write a quick website and just deploy it on Google Cloud. Or for example, you're using Google Drive on your phone, you're using iCloud, and these are all software as a service, which is actually part of the cloud, and you're using it. And then we have tech companies that leverage the services provided by these cloud providers to deploy their solutions to offer more services to us, the end users. And two examples I've given there are Paystack and InterSwitch. So I'm going to explain a few terms. I will skip some of them since they've been explained by Bukola. That's infrastructure as a service, platform as a service, and software as a service. So first of all, I would like to explain containers. Now, this stuff, why I'm explaining them is I might mention them at some point in this presentation, and I would like everybody to follow me. So I'm going to explain containers now. Containers is a unit of software that contains all the dependencies that an application needs to run. So containers basically were invented to stop the popular thing that happens. A developer might have finished writing an application, and when it reaches time to demo that app, you put it on the demo server and it doesn't work. So basically, what containers were invented for is if you run that application in a container on your system and lift that container and run it, and you run it somewhere else, it would run the exact same way it was running on your system. For virtualization, basically it is the process of simulating computing resources and abstracting them from the physical hardware. So for virtualization, there's storage virtualization, there's compute virtualization, which provides RAM, CPU, and then there's network virtualization. So two key players in this part. You can read up on VMware and Hyper-V. So they are the technologies that power the private cloud. Cloud native just means it's a term used to define an application and also a way of thinking. So when you say something is cloud native, it means it was designed to make full use of the advantages that cloud has to offer, which is on-demand computing, basically. And then it has also been used to describe applications that are deployed with the microservices architecture. A stateless application is an application that runs without storing data that it needs to run to the compute device that it is running directly from. So it will still be storing states, just that it doesn't store it where it is currently running. So what this helps it to do is you can lift that application and deploy it somewhere else without needing to move the storage and everything that application uses to run. DevOps. So Chidebube talked about this a bit, but DevOps, development operations, is practices and activities that a software company uses to make sure that its application can reach its end users in high quality and as swiftly as possible. So yeah. So I'm going to be using three ladies, Bola, Amaka, and Halima, to explain the three roles I want to explain, which is a cloud solutions architect, a cloud operations engineer, and a DevOps SRE engineer. So yeah, this is Bola. So Bola is a cloud solutions architect for a consulting cloud provider. So she doesn't work for a cloud provider that actually provides the technology. She works for a cloud provider that does consulting. In other words, she works for a cloud provider that helps other companies get their application on the cloud. So basically, what a cloud solutions architect like her would do, in her role, she is more like a pre-sales engineer. So what her role would be, for example, if a client came to meet the company she was working for and said, we want to run our app applications on the cloud. We're currently running them from a server in our office, and we want to use the cloud to run these apps. What Bola is supposed to do at this point is she is supposed to provide consultancy services to that company. So to do this, she needs to be a subject matter expert. So she needs to know exactly, okay, you are running this app application in this current kind of in an environment. It's a Java application, it's a JavaScript app application, it's this, it's that. So she needs to know, okay, why do you exactly want to move to the cloud? What is your reason? Do you think moving to the cloud will be cheaper? Or do you think you want to expand, that's why you need to move to the cloud? Or are you just moving to the cloud because you've heard cloud and you feel this is why you need to move to the cloud? So these are the type of questions she would ask the customer that wants to move their app applications to the cloud, and to be able to actually give them the correct guidance that they need. She needs to know enough about the services provided by, whether it's AWS or Azure or GCP. She needs to know, okay, the application that you're currently running now, we can move it to the cloud, and I either use the IaaS or we can use the PaaS or SaaS that we have in the cloud. So it just depends on what that company's budget is, the technical capacity that they have, and stuff like that. So I would give you an example. So if someone was running a server now, that the web server and the actual app application was running on the same server, and they have just one IT guy, and they came to meet Bola to say they want to move to the cloud. If Bola, just off the top of her head, because she has heard about containers now, and she would say, okay, I want you guys to move this app application to a container. That would be bad advice, because they have just one in-house guy. So if they move to a container now, for example, if the app application were to stop running when it were on premise, the tech guy could easily just go into that PC, check the logs, and find out exactly why it stopped running, fix it, and the app is back up. But if Bola moves it to a container now, she is making that entire application more complex for the organization to manage. So they will now need to be bothered about the container runtime, they would need to be bothered about pushing their logs from there somewhere else. Because if that container goes down and the logs were not being sent somewhere else, the dev guy wouldn't be able to see those logs and he wouldn't be able to fix. And also, decisions like this are the things Bola would get to make. So for example, she would also help them to pick between a specific service that is provided by AWS versus one provided by GCP versus one provided by Azure. And in making this decision, she would actually need to know what are the advantages I would get over you using this than using the one from Azure and using the one from GCP. So I can give you an example. You have Cloud SQL in GCP. You have Azure SQL in Azure, and then you have RDS in AWS. The three of these things do exactly the same thing. They are platform as a service SQL DBs. But before Bola would pick, she would need to know which of them would specifically suit that organization. So reading from here, so I mentioned some things that Bola would need to consider before she actually architected an application for an organization. So there's data sovereignty here, which just means can the company store their data that they're collecting anywhere? So for example, Paystack, for example, cannot just store payments data from their users outside Nigeria. There is a regulation that prohibits that. They might be doing that, I don't know, but there's a regulation that prohibits that. And so they shouldn't be storing the data of users that use that their Paystack application to process payments outside Nigeria. So she also needs to consider how easy it would be to monitor that app, how easy it would be to deploy, and how backup and disaster recovery would be taken into account for that specific app. So let's move to Amaka. So Amaka here is a cloud operations engineer, and like Bukola mentioned before, what a cloud operations engineer does is bringing to reality whatever the cloud architect has designed. So, for example, if Bola had said we need to deploy a DB in AWS, what Bola would do is just to draw out how the architecture of that app is supposed to be, what is supposed to go where, and where everything is supposed to be. But the person that would actually deploy the DB and make some configuration on that DB in order for it to be usable would be Amaka. So what Amaka's job is to configure and deploy, and most times also manage the cloud infrastructure that's owned by an organization. So, Amaka here needs to be able to configure OSs. So, for example, if I needed to configure a web server on Linux, Amaka would need to be able to do that. She would need to be able to actually make the configs, configure networks, configure the backup. She would need to be able to actually containerize an environment and stuff like that. While Bola might not actually know how to do these things in practice, what Bola needs to know is it possible to do this with this? Or can I do this with this else? Or if I don't use this, what else can I use? So Amaka herself would be concerned with actually going in to make those configuration changes and doing all these different things. So a cloud operations engineer is similar to a systems engineer on premise. Now we know that for systems engineers, we can split the roles of systems engineers into network engineers, DB specialist, someone that manages Active Directory and the different stuff like that. But when you move this DB to the cloud, you move the networks to the cloud, you move the Active Directory to the cloud, it becomes the role of the cloud operations engineer to actually configure and manage these different things that have been moving to the cloud. So answering the question of if not knowledge of networks and DBs and everything that you were using on premise is still relevant. Yes, it is. It's still very relevant to the role. So if Amaka was working in an organization that had their own private cloud, she would actually also need to know the virtualization technologies and how to actually take a system and virtualize it. In some cases, she also needs to know how to automate the deployment and configuration of these different services that she's going to be deploying. So like Andrew mentioned earlier, so while knowing how to automate is important, and knowing how to make configuration changes for most of these cloud specific things, if you have fundamental knowledge of how these things work as we use them now, aside from the cloud, it would really help you to actually understand how to go about the configuration of these different things once you move to the cloud. So for example, if you had configured a VPN when you were working on premise, a VPN is, wow. So NEPA has decided to
Okay. All right. Thank you so much, Uchenna. I think there was a power outage where he was. Thank you so much for taking us through the life of two beautiful cloud engineers, Bola and Amaka. We couldn't take the third person, but it's all right. We would eventually find out through his slides when he gets to share them. Okay, so the last speaker for this section, and apparently the last speaker for today, is going a couple of questions about the bootcamp, starting what are the requirements and all of that. And I actually skipped them because I know that in the last section, we are going to be addressing all of your questions. So we have our founder, that's the founder of She Code Africa, Ada Nduka Oyom, and she's coming up on stage to answer your questions about the bootcamp, let you know everything you need to know about the upcoming bootcamp, the requirements, and everything. All right, so Ada, I hope you're right here. Yes, she is. Welcome on stage, Ada. It's so nice to have you.
Thank you. Hi, everyone. How are we all doing? My apologies on behalf of Uche. We all know, if you're from Nigeria, you all know how erratic the power supply can be. So he's still going to come up on stage, but because of time, I would quickly take my session, and then like Amara mentioned earlier on, we would have a Q&A session. So my session is just to throw more light on what the cloud program is all about and how you can participate. I've been seeing a lot of questions on the comment section asking requirements for it and things like that. So I will just give me a few minutes to share my screen. I created some slides, very brief slides, so that while I'm speaking, you can see some of the things that I'll be talking about. Okay. All right. Please let me know if you can see my screen. Okay. All right. So first things first, I just want to say a very big thank you and a big shout out to the Deimos Cloud team for partnering with us to organize this. It's definitely not something you would see everywhere, that people helping communities, organizations build more pipelines in a particular field. So what my slide is just going to talk about is the program, why we're doing it, the reason why we want to start with a particular number, and other details regarding the program. But first things first, I'd like to give you brief info to what She Code Africa is about. So for those of you who don't know, I'm definitely sure there are people who are on this call who are probably just new members of She Code Africa, or just registered for the event and are not members of the community. So if you don't know, She Code Africa is a non-profit organization, which means that everything that we're doing, we make no gains from that. We're doing it because we want to see more women in tech grow from what we're doing. We want to see more women excel in what we're doing. We're a non-profit organization focused on celebrating and empowering women in tech, young girls and women in tech across Africa. We have several members in several African countries, and if you're part of the Slack community, you will notice in our introductions channel, almost every day people are introducing themselves, talking about where they're joining in from different countries. We have members from Nigeria, Ghana, Kenya, Zimbabwe, Uganda, South Africa, and so on and so forth. Some of the countries, I listed them on here. And we're also a growing community of women in tech, as young girls and women in tech. We're over 5,000 women who are in that community. And so far in 2020 alone, these were some of the things that we're able to do. We're able to reach over 2,000 girls and women in 2020 alone. And from our different programs, we're also able to get on board about 100 plus technical mentors. And the technical mentors are mentors who are coming into our different programs, like our mentoring program and things like that, to help people like you become better and excellent at what they do, all for free. So enough of what She Code Africa is about. Now to the program details itself. So the bootcamp is in form of a cohort style. Cohort style meaning it's like batches. There's batch 1, there's batch 2, things like that. But we call it cohort 1, cohort 2. So since this is the first cohort, we're calling it cohort 1, and it's a 3-month program. It's going to be very, very intensive in the sense that, because we're not just taking you through the program to put you out there and say, okay, you're done with the program, that's the end. No, after the program, we are also making sure that the top performance, as people who give us excellent results, we're placing them, we're giving them internship opportunities and saying, okay, from learning, we're moving you straight into the workforce. And then from there, you're picking up a career in cloud engineering. So for 3 months, it's going to be very intensive. And yes, it is specifically targeted at ladies in tech, or women in tech, or girls in tech. As long as you identify with the female gender, it's a program for you, and you are interested in kicking off a career in SRE. So some people might confuse cloud engineering and SRE together. I'm sure all the various speakers that we've had, they've tried to demystify that. This particular bootcamp is going to be focusing more on the SRE field, because under the internship that you'll be taking up the role of an SRE site reliability engineer. And then the program, like I said, is intensive. We're going to be having some of the speakers are also coming in as mentors, so you get the opportunity to work with them. We also have other people coming as mentors, people from IBM, and so on and so forth. They'll be coming in to act as mentors, and then for the 3 months, you're going to be working dedicatedly with them. We're also going to be creating a very dedicated, intense learning path or curriculum, like you might know it as. That curriculum would involve tasks, it will involve projects that you will build, basically giving you practical steps. It's not just about reading resources here and there, but it's mostly about practicing while learning. And then, like I mentioned earlier on, the top 4 program participants will get direct internship opportunities at Deimos Cloud, and also the next top 2 will get nano degree scholarships via Udacity. We're going to be paying for that. And the essence of us doing this is to help you, take you from learning phase to the workforce on its own. I mean, even if you don't get the intern positions and you're among those who get the nano degree scholarship, we both know, or we all understand, that the Udacity nano degree scholarships are scholarships that are very, very recognized. I mean, it's almost like attending a tertiary institution on its own with the kind of learning that you will get. So now, why are we doing this? I'm going to be very brief about this. The reason why we're doing this is 3 reasons specifically. I personally have had several experiences where it's been very, very difficult via the programs we run at She Code Africa and my personal interactions with community, getting or finding women who are into cloud computing fields. And I thought about it and I'm like, okay, what can She Code Africa do to improve this pipeline? We say we want to bring in more women in tech, and now we're looking at specific fields and trying to find out the fields that have lesser number of women. We started with open source because we realized that there are several, there's a lower number of open source female developers, and that's how we started the Women of Oscar initiative. And then I looked at cloud engineering and like, via our mentoring program, when we put out the DevOps track, we get very little to no signups under that. So I was like, okay, we can have a boot camp where we'll take these ladies, give them the specific training that they need, and then put them into the workforce and see if that would help us build that diversity pipeline so that more women can start getting into that field. And that's the major reason why we're doing this. We're trying to build more diversity pipelines in the field. And then another thing is we're lowering entry barriers. If you notice from the chat section, a lot of comments that we've been seeing are things like people asking questions of if I have zero experience, if I'm just starting out, and things like that. A lot of people have no idea what the cloud engineering field entails. A lot of people have little to zero idea on how to get started. And that's why, and the average person in tech, especially in Africa, when you ask them, how can I get into tech? What are the fields into tech? The major fields they will tell you would revolve around web, mobile, design, and things like that. But there's less knowledge on cloud engineering fields. And this is what we're trying to achieve with this program. We want to lower entry barriers into the program or into the field. And then another thing is we want to bridge that knowledge gap between experts and beginners in cloud engineering. From my personal observation, when the people you see in that field are either people who are just starting out with no direction, no idea of where to go, and then people who have been in that field for a very long time and are excelling. There's like a very large gap. Beginners don't know who to reach out to because 1, there's no emphasis on the field, and 2, it's a wide gap reaching out to the experts in that field. And that is one of the problems that this program is trying to solve. Now, what are the benefits of joining this program? I mean, a lot of you already know the benefits, which is why you are partaking in this webinar to also sign up for the bootcamp. But I just want to reiterate it. 1 is that we're giving you free access to learning resources. Now, here's what we do at She Code Africa. We provide you with mentors, we provide you with a community, we also provide you with resources. And if you are really excellent at what you do in one of our specific programs, but you are not buoyant enough because it's going to be remote, you're not buoyant enough to pay for your internet or subscription fees, we take care of that as well. We're doing all of this to make sure that we're mitigating that gap between you achieving the success that you want to and the actions that you're putting in. And then also we're giving you technical expertise from these mentors who are really, really great and who are excelling at their different fields, all for free. And then for the bootcamp, the cloud program or the cloud school, there's also the opportunity to switch from learning to real-time work experience. So it's like a very smooth flow. If you work hard, like I mentioned earlier, we'll give you everything that you need. It's up to you to match the energy that we're bringing. And lastly, there's the recognized nano degree certification opportunity. So these 3 things are the top benefits that you get to partake or you get to gain if you partake in the program. Now, this is one part that I want us to really, if you're looking to partake in this program, this is one part that I want us to focus on very well. That's the application process. The application process, I think a lot of people have this understanding that if they sign up on the form, that's it, they've gotten into the program. No. Once you sign up for this event, it's entirely different from the bootcamp itself, in the sense that you still have to go through the typical application process for the bootcamp. This event, the live stream event that you're watching now, and the Bootcamp are two different activities, though they are mirrored against each other. So for the application process, we have these different phases: the technical assessment phase, the essay questions, application review, and then interview. For the technical assessment phase, just like Bukola mentioned, and I think another speaker mentioned as well, there are some basic knowledge that you need, programming knowledge that you need to be able to partake in, to be able to excel in cloud engineering, basically. And the technical assessment is our own way of finding out if you are really dedicated to that field, or if you've done something as simple as finding out about that field, basic knowledge or basic learning in that particular field. It encompasses of very simple questions. So it's going to be in two parts. Or the questions are going to come in two ways, and you can either choose to attempt any of them, but you have to attempt at least one of them to be able to partake in or to submit the full form. And then there's the essay questions. Essay questions basically is to understand, to know you better, to know your commitment to the program better. Because some people, once they see something is free, they take it for granted, basically, or they don't put in much seriousness into it and think, oh, because it's free, I can do whatever it is I want to do and they will take me in. But that's not how it is. If you reach out to previous participants of our programs, they will tell you how, in as much as we make things free, we make sure that we're only taking the best of the best and people who are looking to really excel in it. So once you submit, we'll look through your application, we'll look through your project that you've submitted internally. When I say project, it's not like a major project. It's just something simple, like a script that you can write really easy. And then if you scale the assessments, you'll be invited for interviews. The interview is very, very basic, to place a face to the name, to know you better, to know if you were the one who filled your form, to get to know if your commitment as to what you put on the form still aligns with when we're interviewing you and things like that. Now, one thing I want to point out here is that the technical assessment, even though it might be a bit simple, please, we do not encourage code plagiarism. As much as possible, when you're creating your solving your technical assessment, writing your solutions for it, please try to be as unique as possible. And also, don't wait till your project or your solution is perfect. As long as it is working and as long as it follows the instructions I was giving on the page, just submit. Don't wait till it's perfect. Another thing is that the application details is applications will go up, just like we mentioned, right after this event. Immediately after this event, applications will go up. In fact, immediately after my talk, applications will go up. I will drop the link to the application page on this slide, and right after my talk, applications will go up. Now, like I mentioned earlier on, even with it being free, doesn't mean that we're accepting everyone. Typically, for all our programs, we get an average of 1,000 applications, 800 to 1,000 applications, which means we're only taking the top 1%. So you can imagine what that 1% might even be, even less than 1%. So what I advise you to do is, please take out time, try to go through the essay questions, take out time to really understand what the project is asking of you, and submit on or before 15th of January, because once the application closes, that's the end of it. Okay. And yeah, so this is the link to the application form. I'm sure it will still go up on our various social media pages, so there's no need to either start asking for the link or something like that. You can always go on there to apply and things like that. And I think that is all from my end. Thank you, Amara. And I'm sure Amara will still call me back up for questions. So please, if you have any questions regarding the program or anything like that, I would be here to take in your questions.
Thank you so much, Ada, for that brief session. And I hope that most of your questions have already been answered, but we would still take our Q&A very briefly. I don't want to waste much of your time. So our speakers will be coming up right now to take some of the questions that I've collated from the chat. Okay, so I'm just taking like just 2 questions. Okay, so you can reach out to our speakers on your spare time to ask them specific questions you might have. So the first question is by Ajoke, and it is targeted specifically at Bukola. She's asking for advice on which of the 3 top cloud providers one should dive in between AWS, GCP, or Azure. Bukola, the
Okay,
question
hi,
is
I'm
for
here.
you.
Yes, okay. So, thank you for the question. If you do like a quick Google search on the most, let me say the most popular of them all, you would get AWS as the most popular, meaning more jobs, more clients, more people are using AWS. And then next is Azure and then GCP. So if you want to take it in that order, so I would advise starting with the AWS or the Azure based on what you read on or what you're interested in generally, because Azure doesn't have as much will I say AWS has more
Okay.
features than the Azure has. So it depends on really I'll say it's based on you, but generally if you're job searching, you're most likely to see more AWS related jobs than the rest. Thank you.
All right. Okay, thank you so much for that. All right. Okay, and the next question is asked by 3 persons. So I merged your questions together, Adetayo, Obianuju, Adams, and I think this question would be best answered by you, Ada. They're asking if a complete novice at programming can join the bootcamp, and will there be some programming classes during the bootcamp, or you have to know programming before you join? That's the question.
So yes, you have to have very basic understanding at least of the field of programming, because even to partake in technical assessments, you need to understand some things like scripting, some things like how to use GitHub, some things like working with Docker, those basic things. And there's no crime in reaching out to older colleagues in tech to help you in working on your technical assessment. Doesn't mean that you should give them the entire project to work on. I mean, you can reach out to them for help, but yes, you need at least the most basic of all. And I think all the speakers who came on here talked about this. You need, if you're a total novice, it's like saying you want to start schooling from secondary school or from tertiary institution rather than starting from primary level.
Okay. All right, thank you very much. I guess this is the much you can take in this Q&A because of our time. Thank you to our speakers, Bukola. Thanks to our founder, Ada, and thank you, Uchenebed. It was awesome to have you in this platform today. And with this, we are wrapping up with the event for today. Yeah, bye, Ada. With this, we are wrapping up with the event for today. And wow, it's been 2 hours. So if you join this event from section 1, I mean, you're the real MVP. So yeah, the link to the event registration is up. So I'd encourage you to go, rush, read through the questions and the assessments and get right into it. Okay, and the application deadline is 15th. So the earlier you get started, the better. Thank you all so much once again for coming to this event today and being a part of it. Don't forget to share about the program via your social media handles and tag She Code Africa and Demos Cloud. Also, feel free to join She Code Africa community on Slack through our link, which will be dropping in the chat section. Thank you all once again for joining me. I hope you enjoyed the event and I hope to see you in the bootcamp. Bye.